Good morning, everyone. Can you hear? So, as discussed, right? So, we are going to discuss about this data warehouse concept, primary key, foreign key, and types of facts and details, and types of models that we have, along with how we are going to build the relationships in Power BI. Okay, this data warehouse concepts will be helpful to understand the data modeling part. Okay, so we have a model view is there in Power BI application. To get it understand difference between the keys, the type of model that we are going to design, the relationships that we are going to handle. Okay. Before discussing this topic, anybody interested? I mean, like, want to share something? I mean, like the previous examples, right? Do you have any queries or else you stuck it somewhere? Okay. Maybe if you are not understood at the some part of, I mean, transformations that we discussed. If you have any queries, please post it so that I'm okay to discuss and then we will move forward to this agenda. Everyone sure that we have completed that data, I mean like data transformations activities, best practices along with the manufacturing project. I'm asking about best practices because once we move on to this topic, right, new topics on the data modeling, it's again uh, moving back is difficult, right? So that's why I'm just asking now, if you have any queries at the best practices part or manufacturing project data transformations level, please ping in the chat box or else raise your hand so that I'm ready to discuss. If everyone okay, we will work on this. Clear, not clear? You can tell me. Try to respond in the chat box, please. Everyone. One more example shall we discuss? I mean, general example only, which I come to know. One more example on the data transformations part. Shall we discuss one more example? If you are okay. Anybody interested to share your screen so that I will guide it? Anybody interested? See here, to navigate to the data transformation, click on the transform tab. Okay, transform tab. This is your formula bar. So if it is not enabled, go to the views tab, click on the views tab, try to enable it. Okay, this one, check mark, enable it. So what it is giving to you? So it is giving the backend M functions. This is the M function, stable dot transform column name, column type is the M function. So whatever the steps, okay, their data transformation steps that has been available on the right hand side, you can see the backend formula here. This is the formula bar here. Okay. And to see the complete steps, these are all the data transformation steps, right? Individually, we know by selecting this step, right, we can see the formula. If you want to see all the data transformation steps, what is the option? If you want to see the all the data transformation steps in one shot, all the formulas in one go, what is the option? Important. I already discussed that part also, where we have to go and check that all the data transformation steps in one shot. Where it is? You are seeing, right? If I'm selecting here, this is my formula, the first step, second step, right? Third one, fourth, fifth, and sixth. I want to see all the formulas in one go. Where we can do that? In which tab? What is the option to navigate there? Anybody? Important, please respond. If you're not aware, I'm ready to tell. Okay. Don't keep us silence. Okay. Not the query dependency view, advanced query editor. Okay. See here, here, home tab, advanced query editor. Here we can see all the data transformation steps. So query dependency view is where which table is getting loaded onto the Power BI desktop, which table you have been disabled in the query editor, query editor level. So that is available in the views tab here. Okay, query dependency view. So from the source part to the destination, which tables it will be get loaded? See here. By selecting the source, okay, this is the path, right? The source extraction path. What are the tables that is related to it? Which tables has been loaded? What are the tables that has been disabled? This information we get to know by using this query dependency view. Okay. By selecting this source, this is the path, access DB path. These are the tables. The highlighted ones are the tables are going to load to the Power BI desktop. You can see the load or load disabled. The options are clearly visible to you. Understood now? What is the query dependency view? Is that clear? One more example. Okay, it's maybe still if you have any queries on the merge transformations part, it will rectify now. One second. Before navigating to this agenda, one second. One example we'll discuss. It's something like a bank treat website. Okay, it's a bank treat and their retirement. Okay, which state is the best one? What is the crime rate there? Okay, what is the temperature? These details are available. So if you can navigate little down right, you can see some information. Okay, it's related to bank rate statistics. Okay, one second. And their cost of living, these details are available. 1 minute. Huh? There is a data previously where I'm able to see like showcase you the complete USA states wise. Okay. What is the crime rate there? What is the cost of living? Those details. I'm just checking the info. 1 minute. It's a public websites, right? They changed. I think so. Let me check. 1 minute. One second. I have already extracted the data. Give me a minute. 1 second. I'm just stopping my screen share. Give me a minute. I will import it. 1. Let me share my screen. Let me know it is visible to you. Can you see my screen? Same website. Okay, maybe that is available in the down part. Okay. Previously, I'm able to see in the top level itself. Just try to check whether you are able to see this data or not. I'm posting this link in the chat. Just select the URL. Okay. Let me know if you're able to see this data set or not. You're able to see something like a state, overall rank, what is the affordability rate, health and cost care, well-being, weather, crime rate. Okay. So these are the states. If you're observing, I'm going to download this data set. Download it. Download. We are not able to extract directly. Okay. Even though that is a website, we don't have an option to extract the data from a web because there is some confidentiality on the web level. They are providing that information in the form of CSV format. We can download it. Okay. I'm downloading the file. CSV file. Giving the name as Banklet. Download it. Okay. Please download. Here, the requirement is from one of the source system, we are going to extract CSV file format, which is having the information of their state level data. See here, state, overall rank, affordability, healthcare, okay, well-being, weather, and rank. And there is one more website, okay, one more website. We are going to see the data, how it looks like. One more website. It's related to their abbreviations like a ISO code, okay, a kind of pin code, right? Two digits or as a 3 digits pin code. If you're observing in this particular USA state and territory abbreviations, you can see the state-wise information along with ISO code, ANSI code, okay, and their postal information and then other details. The thing is, we have to extract the data from Excel file or else CSV file, which I have downloaded now. And another data source is an web extraction. From this web data extraction, you have to fetch this information. Okay, you have to get this information, and we have to bring this ISO code only, this ISO International Standard Organization, this particular column into your main bank rate data set. Understood? You are going to extract the data from CSV source format, and another source is web data extraction, which is holding ISO code and ANSI details. Okay. From these two tables, what is expected is from the second source system, web, we have to fetch ISO code to be get added to the main bank rate table. Okay. So that is what the expectation is. You got the clarity or else any confusion in understanding? Please let me know. I will share you this link also in the chat box. Is that clear to everyone? Two links. From the first link, you have to download the data set. And from the second link, you have to directly connect it to the web. So you have to connect directly. Is that clear or else any queries? You want me to showcase? Or else any volunteer, raise your hand. I'm going to guide you so that we can complete it. You want me to do it or else any volunteer from your end? It's a hands-on, right? Fine. I will showcase, but you can practice later. Okay, don't forget. See here, I'm extracting the data. Please focus here. Please observe. The first source is an CSV source format, text or CSV. Try to pull the file. Okay, bank rate is my data set. Bank rate. Open. Whenever you are trying to extract the CSV files, and it's very important when you are extracting the CSV file and Excel file, the difference. Okay, whenever if you are extracting the file source type CSV, you can see these operations. Okay, file origin, delimiter is the comma separator, and data type detection is based on first 200 records only. Okay, and this option is we are already aware, extract table using example. That means if you want to create a custom table, like only few columns you're expecting, by using this particular option, we can get this. So what I will do, I'm not going to load it. I will try to make use of transform data. Click on the transform data. Now another source is a web data extraction. Website wise, I'm going to extract some info, which is holding the abbreviations and ISO key standards. Okay, let's try to extract it. Web, provide the path. Select OK. It's a website data, right? For this also you can see column, example operation. Okay, example functionality. Add table using example functionality for CSV and text along with, this web data extraction. You can see an option, add table using example. That means we can generate some custom tables. Important functionality. This is important functionality, and also in the interview part, you'll get a question, which data source operations we can see, add table using example, CSV, text data source, and web data extraction. You can see this option. Okay. So from this HTML, so you can see these many tables, right? See here. You can tell me, can I consider the first table itself? Code and abbreviations for US states. Another tables are providing some details, which is like maybe the extensions or else the full form of it. Is these tables are helpful to you? You can tell. In this HTML tables, in this particular folder, remaining tables are not required. We are observing. No need to import it. This particular first table itself is fine to load it. Extract it. Okay. Select OK. First table is fine. Select OK. So I have extracted. We have to clean up this data set. Okay. See here. It's a web data, right? We're showcasing as a column 1, column 2, and so on. Still. So I want to remove. Can someone please help me here? I want to remove the first 3 records, or else maybe first 2 record, first record only. You can tell me. Only first record I want to remove it. Only first record. Can I delete it? First record, how to remove it? Only the first row. We already discussed about it. Here we have a transformation that is remove it. Okay. Remove first record. Provide the number. Now I want to promote the first row as a column header. I'm just trying to promoting first row as a column header. And this row is not useful for my analysis. Remove this. So these are the transformations that I have performed, and these are the right column headers. Okay, right column headers. Now you can tell me, by observing these two data set, what is a common column here? Did you find out any common column? Any common column is available. Please focus. 10 columns, ISO, ANSI, UPSC, name and the state status of the region. Another table, bank rate, state, overall rank, affordability, cost of living, well-being, and weather rate. Between these two tables, what is common? Which column is common here? There is no common column. See, as per my observation, bank rate, state is matching with name and status of the region. So these are all the states only, right? These are all the states only. In USA, these are all the states. So this particular information, that to ISO code, this particular column from this table, second table, I want to bring into this bank rate. Okay. I don't want to load this as a separate table and work on the data modeling part. I want to bring this particular ISO code column to this bank rate data set. So to do that, are we going to use merge queries or append queries? You can decide. You can tell me. Are we going to work with these? Which one? Append queries or else merge queries? Still, if you say append means you are not very clear. You are not clear. Only one particular column you are expecting, that is ISO code. But here you have identified the common column, that is state is matching with this states. Though the column header is different, this is information is matching. To get this done, select your primary table, bank rate, merge queries. Okay, try to select the merge queries. Use the second table. Here already the current table is the bank rate. Second table is code and abbreviations. By default, join type is left outer join. All the records from the first table, matching records, okay, based on the common column, that is the state column, okay, from the selection. See here, I'm selecting here from this state, okay, I'm selecting this state. It will give the estimation of the number of records are matching and try to select it. That's what we have to do when you are working with merge queries. Okay, select it. Continue. Data privacy, because I have extracted the data from the web. Put it as a public. Don't select any other. Ignore privacy settings or something. It's a public website, right? Try to select public. Which one is a public website? Which one is the public website? Is that a bank rate or else a code and abbreviations? I have extracted the data from a web. Is that a bank rate or else a code and abbreviations? Bank rate is CSV file, right? I have extracted the web, that is coding standards, okay, ISO code. That's the public. Try to define the data sensitivity, that is public. Okay, save it. Save. It will be get loaded. You can see the table information here. New table. See this? So from this table, you are fetching the data of ISO code. Try to select, remove the prefix. Okay, that's it. So these are the ISO code standards. US-IA. Maybe IA means, IA or else LA, I don't know. Lower. So here, these are the ISO codes. See here, US-D. Okay. So is that matching right? You can tell. Just try to reorder it. Reorder. Is that both are matching? ISO codes are matching here or something different? California, US-CA, Florida. Okay. This particular column I have brought from another table, that is a code and abbreviations, by using a merge queries transformation. Okay, we have brought and just try to arrange it in proper order. For that, we have used merge queries transformation. We will not use the append transformation here. Okay. So this table is not required to load. We know how to disable. Disable it. Try to click close and apply. To affect those transformations, you can try to close and apply. That's it. Okay. The table will be get loaded now. 51 records total. 51 records in total. Here. So I have already shared the links with you here. Please try to complete the last assignment. Okay. So see here, as a part of the data warehouse concepts, these are very, very important. The modeling part. In Power BI, we have a data modeling activities. You can try to understand the primary key, foreign key importance, then it is very easy for us to build the data model in Power BI. Okay, so these are the very important topics and also very important of the interview prospect. In interviews, you'll get these questions too. Okay, with them. Maybe they will ask you with some scenario examples as well. I'm providing with example as well as the theoretical definition. I will explain in the practical way. I already explained it. I will re-explain one more time in the Power BI data model. Okay, data model level, we have some designs, right? Data and as well as the modeling level. I will explain it one more time, okay, which is very, very important. Please observe. How can we identify a primary key? So see here, there is a table, person ID, last name, first name, and age. So here we are going to consider the ID column as the key column. And if it is not having any repetition, that means it should be a unique and it should not have any repeated or else null value. That key column, we are going to consider it as a primary key. Example, person table. I have a person ID column with 1, 2, 3 records. There is no repetition here, unique records. This type of a key column, we are going to consider it as a primary key. Very simple. Okay. This column, primary ID column, we are going to consider it as a primary key here because it's not having any repeated records and there is no null information or else blank information. Okay. So vice versa, if you're observing the primary key, right? Foreign key. Assume that there is an order table, one more table other than the person table, and you have identified a similar product ID, sorry, person ID column here, on the order table. And there is some records are repeated. So maybe the particular person having, same person is having two different order numbers. Okay, the repetition is there. Person ID is repeated a couple of times. Okay. Or maybe there is any null or else a duplicate of information. That particular key column, we are going to consider it as a foreign key of the table. Okay. To bring the relationship between two tables, one table should be a primary key, one of the key column, and the another table, any one of the field, existing field, should be a foreign key. Example, very simple example from our end. Manufacturer table. See here. Simple example is manufacturer and product table. Okay, these two tables. Manufacturer table is having 14 different manufacturers. So manufacturer ID here is foreign key. Correct? Manufacturer ID is the foreign key here. Is that a foreign key or else a primary key? Is that a PK or else FK? Please observe. It's a primary key. No repetitions and there is no blank or else null information. 14 records. Very simple data set. And coming to this product table, I have identified the similar column manufacturer ID here. Okay. And here the repeated records are there. Manufacturer ID is repeated. This ID is repeated. 12 is repeated. Maybe we don't know, there is some blanks also. So repeated records are available. So coming to this model, if you are observing, we will not call it as a PK or as FK. Here we will call it as a one stands on the manufacturing side, one side, and a star. A star stands on the product table side. That is the manufacturer ID. So whenever if you are trying to hover on this line, the key columns are getting highlighted. See here. Key columns are getting highlighted. Even you can observe in the properties window, product table, manufacturing table, and the key columns. Manufacturer ID is the key column here. Okay. So star stands for many. So product table star, manufacturing ID column is having repeated records. So foreign key, simple name. So in interviews part also try to explain practically, okay, not in a theoretical fashion, try to explain the practical mode. Just to try to give some example, ID column take, some categorical data like last name, first name, age. An order table, some stats, simple data set, order ID, order number, and the same person is having some repeated order, different orders, same person ID. So Peterson is having two different orders. So try to give that example so that it's easy for the interviewer. Okay, you know something on this. Okay, this field are as a key items. Okay, fine. So another important, what is a fact? So fact table is nothing but which is going to hold an important metric, number related statistics. Okay, numbers. Basically, fact table is going to hold a measures or else a metric and other quantifiable information, which is nothing but some important metric information is going to hold. In that facts, there are three types of ways. Okay, three types of facts are available. Additive fact, semi-additive, non-additive. So if someone will ask you, what is a fact table means? A fact table which is going to hold only the metrics. You know the meaning of the metrics, right? Important key columns, important business derivable formulas are also functionalities. Important metrics, numbers, okay, numerical related information. That is nothing but a fact. So in that, we have three different types of facts: additive fact, semi-additive, non-additive. Please ignore the factless fact table as of now. So that's why I just move a little bit down. So three types of facts are there: additive fact, semi-additive, non-additive. We will discuss one by one. Fact table itself is nothing but which is going to hold some important measures, metric. These are all the technical names. Okay, if they are calling it as a measures, it's a number. If they're calling it as a metric, it's also a number. Numeric information is also a number. You know the difference, right? And other quantifiable, okay, derivable information. So here, additive fact, the first one is an additive fact. Additive fact is something which is going to support all the aggregation functionalities. Like example, sum is an aggregation. We worked on the group by, right? There we have some average, minimum value, max, count. These are all the aggregation functionalities. A field which is going to support any type of an aggregation. That means addition, subtraction, okay, average, and also try to find out the maximum value or else a minimum value. That particular key field column, we are going to call it as an additive facts. The example I have provided, quantity and sales amount. In our data set, in our current project manufacturing, can you please help me in the sales table? What is additive fact here? One example, please. One example here. Is that a product ID or else a revenue? Is that a product ID? I'm giving you an option, a product ID or else a revenue. Which one is an additive fact here? Revenue field, we can perform either the summation or else an average or else to try to find out the maximum or else try to find out the count, anything it will be get supported. That is revenue field or unit also we can consider. Unit field is also, we are going to consider it as an additive fact only. Okay. So additive fact is something which is going to support any type of an aggregation which has been listed. So I'm providing the list here on the right hand side. So see this right hand side, I'm providing some average, min, max, count. Is that a standard deviation or else a variant? Any type of aggregation, if it is supporting in the sense, that is nothing but an additive fact. Next, what is a semi-additive fact? A fact which is going to support partially the aggregation functions. Partially in the sense, some of the aggregation functions, it will be get supported. Like example, bank account details. In that bank balance, we are going to consider it to get minimum balance I'm maintaining in my account or maximum balance I'm having that in my account, bank account. So one particular key field, I'm going to consider any one of it. It is the maximum value I have to calculate as minimum value. So which is going to support partially, okay, some of the functionality, some of the function which has been listed on your right hand side. Okay, example I have provided bank account details, that is bank balance. Partially, if we are supporting few of the aggregations, that one we are going to consider as an semi-additive fact. Okay, clear? Like that, we have one more non-additive fact. I mean, it's simple, right? If it is not supporting any of the aggregation function, that particular function, the name itself is saying non-additive fact. Okay. If it is not supporting any of the aggregation function which has been listed on your right hand side, that particular field, we are going to consider it as a non-additive fact. Example, try to calculate a percentage. For percentage calculation, we will not use any of the sum, average, minimum value, maximum value, right? It's a calculation, it's a ratio calculation. We will not use any aggregation functionality. It's a ratio calculation. So example I have provided, like attendance details, attendance percentage. Okay, attendance percentages. So that particular key columns we are going to consider it as a non-additive fact. So here we discussed about fact table, which is going to hold a key metric information. In that, we have three different types of facts: additive, semi-additive, and non-additive. Additive fact will support all the key aggregation functionalities. Semi-additive facts is going to support partial, okay, or some of the aggregation functionalities. Example, bank balance. And non-additive fact is not going to support any of the aggregation functions which has been listed, like sum, average, count, or as mean area. Example, attendance, or else trying to calculate a percentages. Okay. Important on the interview spot. So they will ask you about examples. Okay, can you please explain me with one example which will get supported with a non-additive fact? You have to tell one example. Okay. Like that, we have a factless fact table. So a fact table which doesn't have any number, any measure or as a number or as a metric. That one we are going to consider it as an factless fact table. Fact itself is a number, a table which is holding with not worthy of any number. That key field we are going to consider it as an factless fact table. Example, if someone will ask you, what is an example for that? Try to give the example as a product ID, manufacturing ID, or else date ID. These are all examples of factless fact table. So for the date ID column, can we perform a sum of date? Can we perform a date, sum of date? Expecting an answer here. Example here, in our date table, can we do a sum of dates or else average of dates? Can we do that? Example here itself, I'm providing. Or else a month number. Can we do the sum of month number? Sum of or else average of? No, right? We cannot perform that sum here or else average. So these are all ID columns. We are going to consider it as a here also manufacturing ID is there. I can perform a count here, count of manufacturing IDs. I cannot perform the summation. Correct? Agree with the statement? Right? Like that, we have to identify. Okay. So here also, if you're observing sales table, revenue and units, which is having an icon of sigma symbol. Sigma stands for a measure, metric, number. I'm giving three different names: measure or else a metric or else a number. So are we going to perform on this revenue sum, average, count, min, max? Can we do that in this particular column? Is that possible? Yes? No? Yes, right. Revenue I can perform sum, average, min, max, count, anything. So it's a number. It is defined here. Sigma symbol. It's a sigma icon. Like that, you have a product table. Product table is there. Can we perform a sum of product ID? Average of product ID. Can we do that? No. Some aggregation functionalities we cannot perform here, but I can perform the count of product ID. Yes, I can perform count of product IDs. Correct? Can I perform it? Count of distinct count of product IDs. How many products are there? I can perform. So partially it is getting supported. That means example, which fact it is? Is that a semi-additive or else additive fact or else non-additive? Good. Semi-additive facts. Is that a sales table, revenue and units column? Is that a semi-additive, non-additive or else additive? Expecting an answers here quickly. Try to respond. It's an additive. I can perform any of the operation, any of the aggregation function. Okay. Like that, factless fact table. Factless fact table. So example is the date field. Can we do that? Any of the aggregation, even the count or else sum. Can we do that? Here is a maximum, minimum. No, I cannot perform it. Date ID column or as a date column. Factless fact table information. Date ID or as a product ID. These are all factless fact tables. Okay. Try to remember important. Okay. Like that, we have a dimension table, which is going to hold the description of the product or else some categorical info. Dimension table is going to hold description of that particular product. So here in our product table, we have the descriptions like, see this product table is our example. Description, some segment, these are the different categorical steps, categorical info. Like that, these are the different types of products which has been getting manufactured from their companies. Even this is the product code. These are the different types of products. It's giving some description. Like a location. These are the categories. Canada, France, Germany, Mexico, and US. Description. So product table, I'm going to consider it as a dimension table. because it's giving the complete description to my source system, source or else a visualization part. Like that, manufacturer table. Manufacturer table, it is giving the description, manufacturer ID and the manufacturer, right? Like that, date table is always a dimension table, which is having the description only. I cannot perform any sum or else any type of an aggregation. I can see the description of the info, like categorical data, like a day-wise information, Saturday to Monday. Okay, month number, which is again a categorical stuff. Month name, like from Jan to December, you can see it from here. Okay, so description. So date is a dimension table here. It's providing the description. Now I'm expecting an answers from you by observing the location table. You can tell me, is this a dimension table or else a fact table? Is this location table is a dimension or else a fact table? You can tell me now. Fact. One person saying the fact table. So how it is a fact table? Can you please help me? Is there any important metric is available? Is there any important metric is available? Like a number is available? Is that a zip code is a number? You can tell me, please. Maybe in that we have a textual data too. See here. Textual data is also available. It's not a number, right? So is that a dimension or as a fact table? Simple question. Joshi, please tell me. It's providing some categorical data, right? Priya, you are also confusing. Is that a fact table or is a dimension table? Simple question. Did you find any important metric here? Number here? Priya or someone? Whoever saying the fact table. Is there any important metric? Number you find it? Yeah, no number, right? All are categorical data. State is a category. It's giving some description of the each and every location. Like that, region is again one more. These are the four categories: central, east, west, or south. Like a cities, country. There is no important metric. Then how can we consider this as a fact table? Right? It's not a fact. It's a dimension. Now you can tell me by observing the sales statistic data set, is this a fact table or is a dimension table? It's purely a fact table. Why you are saying it as a purely a fact table? I found out very important metrics like revenue is there, unit is also a very important metric. Maybe if I have identified the quantity, unit price and all, it's completely purely a fact table. So here, though we have a product ID, date, zip code, but here I have identified very important metric, that is units and revenue. So I'm going to consider in this particular manufacturing project, sales table is my fact table. Okay, it's a fact table. It's a fact level info. Yes. Now it is clear, right? From these 5 tables, you are clear or else any confusions? These 5 tables. You are clear. Everyone clear about fact and dimension, or still any confusion? This I'm ready to explain. Next, moving on to the next slide. See here, center, if you are observing, sales part, which is having the foreign key. FK stands for foreign key. And very important metrics like a quantity, amount, average sales. Okay, sales info is there. In center, you have very important metrics and along with some foreign key details. And other tables, if you are observing, there are 4 different tables: time dimension table, location dimension table, item, it's giving the item details, branch dimension table, like a branch ID, owner, and branch location names. So centrally, there is a fact table surrounded by multiple dimensions. Okay, surrounded in the sense rounding off. Okay, circle wise multiple dimensions. And it is directly all the dimension tables, if you are observing, directly connected to the central located fact table. That schema design, we are going to call it as a star schema. Centrally located with one fact table, surrounded by multiple dimensions and connected in the form of one side to the many. Okay, one side means primary key, foreign key. Many side is foreign key. That schema design, we are going to call it as a star schema. It looks like a star. Okay, like that. See here, few more examples. See here. Centrally, if you're observing fact reseller sales, one table is there. And if you're observing the remaining all dimensions, like dimension product, or dimension date, or dimension resellers, dimension employee, sales territory. These are all the tables are surrounded and directly connected to the centrally located fact reseller sales. That schema design, we are going to call it as a star schema. Still, if you have any queries or else any confusions, here it will be get clarified. Okay. One more example. Okay, similar one, I just to come up with multiple slides, okay, with a different snapshots. See here, slowly I'm navigating to our model part, model view level. Dimension side, one side is there, one is available. See here, arrow mark is pointing to the one. And below that, fact side, it's showcasing the star, which is nothing but a many. So centrally, you have identified the fact information center, okay, or else in the middle. And remaining all dimensions are surrounded just like a star. This schema design, we are going to call it as a star schema design or model. Okay, model also we can say. So most of the times to get the good performance of the report development, which we are going to complete, we are going to do it in the form of a star schema approach. Okay, star schema design is the best way of designing and building the data model for the report development. Okay, there are some scenarios where we can try to build another approach. Okay, not only the star schema, there is one more schema design. That one we are going to call it as a snowflake schema. So if you are observing, I'm not good at the designing, but see here, I mean drawing part, which I have square box in the center. Can you please tell me the highlighted square box? Okay, how it looks like? Centrally, you have a revenue table, dealer table is there, branch table, product table, and date dimension table, which has been surrounded. How it looks like to you? Just to focus on the centrally highlighted one. How it looks like? Is that a star schema or else a snowflake schema? Just to focus on this part only. Okay, don't consider any other tables. So this is star schema. Okay, the highlighted one, which is the square box. And if you're observing, the dealer table is having some more hierarchy, like is giving some additional information, like a region information. So it is giving some additional information and providing a hierarchy with a dimension to the another dimension table. So that schema design, if you are observing the same country table as a country details also it is providing in the form of a hierarchy, hierarchical order. Okay, it's been extension or else expanding with additional information, additional dimension tables. That schema design, we are going to call it as a snowflake schema. Okay, snowflake. Star schema is there, snowflake schema is there. Snowflake schema is an extension of a star schema. It gives an additional dimension table and it will get connected with your dimension table to the another dimension table. Primary and foreign key stacks. This schema design, we are going to call it as the snowflake schema. Okay. So the dimension table are normalized here, which splits the data with additional tables, additional sub tables also we can say simply for our understanding is a kind of a sub tables, right? So dealer dimension table is having some sub tables and this is having a hierarchy and connectivity with main table to the subtable, main dimension table to the subtable. Suppose these subtables are directly connected to the fact table. What is the schema? Which schema it is? With these location and countries connected directly to the revenue, which schema design it is? Consider only these two. If it's having the common field to the revenue, then it is a star schema. Without any doubt, we are going to prepare a star schema representation. But here we have a hierarchy within the dimension, and it is having some extension of subtables. This schema design, we are going to call it as a snowflake schema. Okay. So important, please remember. So example is fact resellers table is there, and it is having one dimension. So up to this part, I'm going to consider it as a star schema, but a dimension product is having the hierarchy. Subtables are there, sub product subcategory and product category. This schema, we are going to call it as a snowflake schema. Okay, dimension table is having some subcategorical fields. Okay, like based on it is providing some additional information. So English product subcategory name, it's providing some additional data based on the common column here. Product subcategory key is matching with product subcategory key. Like that, dimension product category is matching here. See this? Product category key, product category. So it's a kind of a hierarchy. So we will call it as a snowflake. Okay. But I'm stopping up to this part. We'll connect Monday. Monday is a holiday, or else I have to check. I'm going to stop it up to now, up to this part. Shall we connect Monday? If there is a holiday, we will connect Wednesday only. I don't know, but once I will get something right. Tuesday is a holiday, right? Monday we have a class, right? Monday morning. Monday morning we will connect them. Monday morning we will connect. Please available. Monday we have the session. Tuesday there is a holiday, I think so, but I'm not sure. I have to get a notify from the Naresh article. Monday we will connect it, okay? But from your end, these theoretical things, please complete it. Read it thoroughly, very simple language. I have written in a very simple language. Please go through it and let me know. If any queries or else any concern. And try to complete the last best practice. Clear? Any queries? Stopping my screen sharing. Any queries? Any queries? Anyway, I'm going to share you the document, right, Joshi? I'm going to share you the PPT, right? PDF or else PPT. You'll get it. Fine. We'll connect Monday. If you have any queries, I will wait for some time. Any queries? I will wait. If you have any queries, I will wait. No queries? Fine. Thanks for joining. Have a nice day. We'll connect Monday, not tomorrow. You want me to take extra means, you please be available, Tejas. Please wait here. I will unmute you. You can speak. I am ready to take extra class also. I mean, maybe the Saturday too. But if you have any queries, I can help you where you are stuck or something. Tejas, if you're stuck at somewhere, please let me know. That's what I'm saying. Fine then. Thanks for joining. Have a nice day. Bye. We'll connect Monday.